I want to talk about what's known as an inductor. And here's a picture of an inductor, okay? It's a coil of wire. And when you pass a current through a coil of wire, it makes a field inside the coil of wire. It works like this. And this is some stuff which is taken from chapter 26. If I have a current going through a coil of wire, it makes a magnetic field. If the magnetic field changes, that's a changing flux inside the coil, and it's going to generate a voltage that opposes that change. So if I have current into this device, and it's increasing, the current's increasing, that's increasing the magnetic field, the device generates a voltage that opposes that increase. And so it gets a positive voltage on this side, negative on that side. And that's going to tend to try to keep the current from increasing. So it develops a voltage to oppose that increase in current. On the other hand, if the current decreases, it's going to try to develop a voltage that will oppose that decrease. And so, in fact, it develops a voltage where it's this polarity. So if you have an inductor, if you have a coil of wire, it's going to oppose the change in current. If it increases, it develops a voltage to keep it from increasing. If it's decreasing, it develops a voltage that tries to keep the current flowing. Okay? And the equation, the basic equation for the voltage across the inductor is this. The voltage is equal to L times delta I, change in current divided by time, where L is the inductance. It's the inductance. And the unit of inductance is the Henry. Okay? Now, mostly, I want to think about inductors as circuit elements. And they look like this. I'll draw a circuit picture that uses an inductor. So I have some sort of AC power supply. And I'm going to draw a simple series circuit that looks like this. It's a series circuit consisting of a resistor and consisting of an inductor. Now, suppose I hook this up to normal household electricity. So this is 120 volts. Some of that voltage will appear across the resistor. Some of it will appear across the inductor. Okay? Because our electricity is AC, it's continually changing direction. And since it's continuously changing, I'm going to always have a voltage across the inductor. Okay? We can associate with this something called the impedance. The impedance. And it's something that's like resistance. And it's proportional to the inductor's inductance. And if it's got a big impedance, it's going to have a big voltage across it. If it's got a small impedance, it'll have a small voltage across it. Okay? And I'm just going to show you an example of that and how this works and the type of thing that you could use it for before we talk about it in any detail. And that's this device right here. This circuit is as I've drawn right here. There's a coil of wire, and it's in series with a light bulb. I'm going to turn on the power. Light bulb lights up. This has a very small inductance, and so it's got a very small impedance. And so most of the voltage appears across the light bulb, and because the voltage is across the light bulb is bright. But I can take this inductor and I can increase its inductance, and I can increase its inductance by increasing the strength of the magnetic field inside it. If I put this iron bar inside the inductor, it'll get magnetized. And that'll increase the magnetic field strength dramatically. Oh, and so therefore I'm going to increase the voltage dramatically. It's going to correspond to an increased inductance. So it would be like having this picture right here. Most of the voltage is across R. If I increase the voltage, if I increase the inductance, most of the voltage will be across the inductor. So what will happen to the light bulb? Less bright. So here we go. Take this iron rod and I put it inside here. And all I'm doing, this is not electrically part of the circuit. It's just this iron which goes inside the core. And it makes the bulb get dimmer. Where have you seen something like this practically? Dimmer switch. This is how a dimmer switch works. You turn a dial, and as you turn a dial, what you're doing is you're changing the inductance of an inductor, and then it changes the voltages, and so you can dim things.